Hello, and here we are for Newton's Bench, lab number 2. This lab is on free fall. Again, my name is Greg Perugini, and I'll be showing you how to do this lab. So, with free fall, you remember the kinematic equations. You should have gotten these in the lecture already. These are the 4 generalized kinematic equations. And your book may use a different notation, but this is velocity final equal velocity initial plus acceleration times time. The x stands for displacement, x final equal x initial. And of course, we have the same notation throughout this. Change in displacement is here. So we have these. So how does this relate to the free fall problem that we're going to be doing? Let's take a look at this third one. If we're dropping something, say the marble that's in your kit, and I'm holding it here, its initial velocity initial is 0. So this part goes away. And then we have only one thing acting upon it, right? The only thing acting upon it is gravity, acceleration due to gravity. That's the A there. So if we consider height as a displacement change, put that on this side, call it h, and use as acceleration here on Earth 9.8 meters per second squared, we end up with a very simplified equation. Height is equal to 1/2 times g, where g is equal to 9.8 meters per second squared on Earth, times time squared. So, with that, we have only one variable per se. There's a constant acceleration due to gravity, or excuse me, 2 variables, height and time. And if you know one of them, you would know the other. And if you know both the height and the time it took for this to fall a particular distance, then you would be able to verify g. And that's what you're going to be doing for this particular experiment. Well, you can use the height that you used in the first lab when we did vectors, or you could come up with another one such as a displacement from a window. If you know the height of a window, we need to know that height for this experiment. And if I was doing something like a bookcase, for instance, or whatever it might be, I can use the tape measure that's found in your kit. Now, the next thing, of course, let's say that I'm dropping it from a window of my house and I know the height to be 5 meters. The second variable that I need, of course, is what? Time. Well, I need to get out of my kit a stopwatch, right? So you have a stopwatch where you time how long it takes from the very point you let go to the time it hits the ground. Now you want to use something fairly high, maybe a high bookcase or something like I'm showing here that is 5 meters high, because otherwise, as you can see, it's a very, very short period of time for it to drop a small distance. So in my case, I dropped from my window and it went 5 meters in, and I timed it, did it 5 times, took 1.02 seconds on average. So in your lab, you want to show the averaging, of course. I did it in 5 trials, as I said. And so I insert those into that free fall equation, do the math, and I get g at about 9.61. Not quite the 9.81 or so that I would get if it was theoretical. And that's one of the things you want to do in your lab, is to say, why are you different from that? So, in conclusion, what you want to do is you want to pick a height of significance. Otherwise, that T is going to be very small and very hard to make use of the stopwatch correctly. You want to fill out the methodology section completely. Needs to be detailed. If it's not detailed with pictures, the grader will not know that you did the experiment correctly or that you even did it at all. So, assume that the grader knows nothing about the experiment. Be very detailed. So, like in your example, you won't get 9.8 meters per second squared. Make sure you explain the reason for the discrepancies between your result and the accepted value of G. And that's the free fall lab.